All right, here's an example we did last time. A piecewise defined function is just that. It's defined in pieces. This part here is your domain. Those are all your possible x values. And this is your range. This is what defines the y values. When you graph this, you graph each of these pieces on the same graph. So what this tells us, for every x less than or equal to 1, I use this function. What kind of graph is this going to be? No. What's the name of this function? What kind of function is this? Starts with L. Yes. Because there's no exponent, no absolute values, no anything. So since it's a line, let's say when x is 1, y is 3. 3 times 1 is 3. When x is, we have to go less than, so when x is 0. 3 times 0 is 0. So when x is 1, is it an open or closed circle at 3? Closed, because it's included. At 0, it's 0. So we know that this part of the graph looks like this. That's this first part of the graph. Now the second graph is for all the x's greater than 1. So what we do is we start at 1, but we make this graph at 1, make it an open circle. So when x equals 1 on this function, what do we get? 4. So it's an open circle there. Because it's not included. 1 is not included. When x is 2, what's the answer? 4. And then x is 3, so it's a horizontal line. So there's the graph there for that one. Pretty straightforward. The only thing you have to remember is you have to do them in pieces. Because this function here, this piecewise defined function is really this. These are the functions. This one is for any x in that domain. And so it tells us what we have. For, this one here? Okay, for this first function, y equals 3x. Since I start off at 1, what's the value? When x is 1, 3 times 1 is 3. Because the function itself is 3x. Since it's linear, since it's a line, all I need is 2 points. And then I connect them, and it's a straight line forever and ever and ever. So I start off at 1, plug it into the function 3x. So 3 times 1 is 3. I have to have x less than 1 now. So I go to 0. 3 times 0 is 0. These are my 2 points. 1, 3, and 0, 0. Those are the 2 points, x, y, x, y. All right, so that's what we did. We also started transformations. Section 5. What is a transformation? Exactly. It's exactly what it is. It's the change of a graph. How many different ways can we change a graph? We have a horizontal shift, which means it's left and right. We have a vertical shift, which is up and down. We have a reflection. We have 2 types of reflections. We have a horizontal and we have a vertical reflection. It's a mirror image of itself. And we have horizontal, shrink, and stretch. And we have a vertical, shrink, and stretch. So we can move the graph up and down, left, right, flip it over, up and down. We could stretch it, we could shrink it up and down, make it wider, skinnier. Now, when does all this stuff happen? All this stuff happens to this function. G of x equals a f of bx plus c plus d. Where a, b, and c are numbers, integers. F is the function and x is the variable. For example, tell me what a, b, c, and d are in this equation. What's a? -1, very good. Because a is in front of the function. The function, what's the function? Absolute value of x, that's it. Because we have to know what function we're dealing with. We did the library functions last time, didn't we? Yeah, so you have to know those 8 library functions because everything relates to those guys. What's B? C? 3, D? -2. B and C are inside the function. D is the only one that doesn't affect the function directly. A is the coefficient. So once you understand what A, B, C, and D are, we can now have a better understanding what's happening here. Horizontal shift. The horizontal shift is dictated by what happens inside the function. It follows the value of C. For example, x plus 3 squared. Whenever you do transformations, the first thing you have to do, decide what the function is. What is the function from the library of functions? So what is the function of our example here? It's what? What is the function? No, here's x, right? It's squared. It's x squared. We need to know that because we need to know the original graph. What does x squared look like? X squared is a parabola. Then we look at, is there a horizontal shift? Again, horizontal shifts occur inside the function. So inside the function, x plus 3 is your horizontal shift. How far does it shift left or right? Which direction? You'd think, no. Remember when we did circles? It's always opposite what's inside the parentheses. Same thing here, because we take whatever's inside the parentheses, set it equal to 0. The reason we do that is because the original graph, when x is 0, y is 0. It's that's the origin. That's where it all starts. So where did it move? Let's put it back to 0. So our new origin is at -3. So our horizontal shift what's happening is our origin is moving to the left 3 spaces. So we have a new origin. The graph looks the same. It's just it's moved 3 to the left. Again, it's always opposite the direction of what's inside the parentheses. Vertical shift happens outside the function. The vertical shift is the D value. So the vertical shift does not affect the X value. It only becomes something after the function has been worked out. So again, the original function is x squared. We know it's a parabola. Now, since nothing else happens to x, we increase it by 2. So it goes up 2 spaces. There's my new origin. So there's my graph. This is what I mean by outside the function. There's nothing, it's not a coefficient. It's not an adjustment inside the function. It's all by itself. It's practically the y-intercept. It's the number, it's all by itself. It's the constant. Let's look at reflections. Let's look at horizontal reflections. Is occur when the sign of x changes. It flips across which axis? The y, very good. The easiest one to see here is with the square root. Does occur have an E at the end of it? Or no? Occur, the word occur.
No, I don't think so.
Okay, make it an S then. It occurs. So I'm waiting to see for a red line under my paper. So is there a horizontal shift? In other words, is there inside the function, is there a plus or minus? No, it's not a minus, it's a negative sign. In other words, is there an x plus or minus a number? That's a horizontal shift. Is there a vertical shift? Is there a number outside the function? No. So now we'll just get a reflection. What do we know about this function? The basic function we're looking at here is square root of x. What does that graph look like? Square root of 0 is 0, square root of 1, it goes like this. Because what are the rules about radicals, square roots? What can you not have inside there?
Negative.
Cannot have a negative. You can have a zero, square root of zero is zero, but you cannot have a negative. So that's why it's the square root of x is going in the positive direction. But if I change the sign of x, what does x have to be to get rid of that negative?
Square, right?
No. You can't just square it. Because you can't, because all you have is this axis to work with, the x-axis. What if x was negative? The value of x was negative. Whereas if I put, there's this negative, what if x was -4? Exactly, so now I have 2. So if I have a negative in front of the x, that means x has to be negative to cancel off that x, which means I have to now use all the negative values. I can use -4, I can use -9. Because I have to cancel out that negative there inside the function. So you see now why when you change the sign of x, it changes the direction of the graph?
Example of the -4, how do you get 2?
What's the square root of 4? Yes. Why is it 2? Here's a question. Why is it 2? Because what this invisible here, a square means it's 2. What a 4 is, it's 2 times 2. As soon as you have 2 of a kind inside there, you can bring it out. That's the reason the square root of 25 is what? 5, because 25 is made up of 5 times 5. There's, once you have a pair of numbers, you can take them out. Okay, so that's a horizontal shape. If x has a negative in front of it, the graph now flips across the y-axis. A vertical reflection. Occurs when the function changes signs. This one flips across the x-axis, hence vertically up and down. Okay, there's a negative sign. Is it inside the function or outside the function? It's outside. Since since the negative's outside the function, it's a vertical flip. The original function is square root of x. That's like this. Now, when I put a negative in front of it, what does that mean? What does that negative in front mean? Why is it going down? So square root can only have positive answers, right? If I put a negative in front of it, what do they become now? These are all positive. When I put a negative in front of it, it becomes negative. That means all the answers are negative. So that's what I'm saying. That's why it flips across the x-axis. If the negative sign's in front, you now change all the answers from being, all the positive answers become negative, all the negative answers become positive. Let's look at this one. Graph that one. There's a negative. Is it inside or outside the function? What's the function? You're close. You're halfway there. The function, if you look at the library of function, it's 1 over x squared. What this equation means is there's a negative and we have 1 over x squared. So what does 1 over x squared look like? Because it's squared, can the answer ever be negative? Can the answer ever be negative? If it's, in other words, if I put a negative number in there, what happens? -2 squared becomes what? Positive, yeah, so always becomes positive. So this one, this graph looks like this. It's the Atari. That's the 1 over x squared function. If I make it negative, what happens to all the values now? All the values become negative. So if the negative is outside the function, then flip the picture across the x-axis.
You said that again.
If the negative, let me write it down. If the negative is outside the function, then flip the graph across the x-axis. Because everything that used to be positive is now negative. Everything that was negative is now positive. Let's look at this one. Let's start mixing up some of these things. Remember what's always the first step? What do you have to figure out?
The function.
Yep. What is the function? So what is the function of this one? From the library of functions. When I said, what is the function from the library of functions? Because that's where we always begin with the basics. Where is the X? Right inside this.
Yeah.
So since the X is there, that means the function that we're dealing with is the cube root function. In other words, when you do that, get rid of anything plus or minus to X. If X has a coefficient, get rid of it. We just want the X by itself inside whatever it is. So there's a function. Why is this important? What does the cube root function look like? What's the graph? I know you know it when I put it up there. Can the answers be positive? No.
Um,
It looks like the square root, but it can also be negative since it's cubed. It can be positive, negative, and zero. So that is the cube root function, the graph of it. What's the first thing that happens to it, to X inside there? There's a negative in front of it. What does that mean to the picture? If it's inside the function, what does it shift over across? Because now all the X's from that used to be positive are now negative X's. So the graph now looks like this. I flipped it across the y-axis. And then here, next one, is there a horizontal shift? In other words, inside the function, is there anything added or subtracted to X? Yes, there's a 2 minus X. So how do we figure out the horizontal shift? Take whatever's inside the function, set it equal to 0. Solve for X. So since X is negative, I'm going to add X to both sides. Equals X, because we're trying to get X by itself in positive. Because if we move the 2, we still have negative X. We have to change the signs. It's just sometimes it's easier to move the X. So that means my new origin starts at X equals 2. So there's my new origin right there. So this graph now crosses through there. It's shifted over 2 spaces to the right. We know it's horizontal because it's happening inside the function. So far, so good. Okay. What do you think would happen? If I gave you this, what would the graph look like?
F of X two minus.
This is negative cube, this is a cube root of X.
Equal sign.
Is it, there. Do it in pieces, piece by piece by piece. What's the original function? Cube root of X, very good. We need to know that because we need to know what the original graph looks like. Again, when you do your homework, it's going to ask you for a couple of points. So you just plug in for X, positive, negative, and 0, and see what happens. But this is the shape of it. So what do you do first? What do you examine? What do you look at first? Yeah, look inside X. What happened to X inside here? It became negative. So what does that mean the graph does? If the X changed from positive to negative, what happens to the graph? Yes, but which horizontally or vertically? Across the y-axis. So it flips this way. Because if it happens inside the function, it flips across the y-axis. And then what else happens to the function? There's a negative in X. That's negative on the outside. What happens to the negative that's on the outside? What does that do to it? Look at your notes. If it's outside the function, what happens to the graph? Flips across the x-axis. So now it goes like this and like this. Goes back to the original function. How about that one? Make it minus 3 minus X. So what's the original function look like? Absolute value of X, very good. What does the graph look like? Yeah, it's a V, very good. The next change that happens inside of it is X becomes negative. Again, you have to start from the X and work your way out. So what happens to the graph? Flips where?
Yeah.
If the change of sign is inside, you flip across the Y-axis. Because the X is, look what happens here. If it's inside, that means the X changes from positive to negative X. So it goes horizontally, which means it flips across the Y-axis. If it's outside, it flips across the X-axis because the Y values change from positive to negative. So that's what happens there. So this thing flips across the Y-axis, so nothing happens. It looks the same. What's the? No, it'll be the same. Because if you put -3 in there, negative of -3 becomes 3. So it'll be the same. Now that this 3 comes here, now that the 3 comes into play, what happens? It's inside the function. There's a plus or minus to the X. So what happens to the graph? Which way? Left, right? Why?
It stays positive, I don't know.
Well, let's see. If it's inside,
Mhm.
take whatever you have, set it equal to 0. So X is equal to 3. So you're right. It shifts to the right. 1, 2, 3 spaces. In other words, there's my new origin. Is it moved from here to here? The graph still looks the same, but it now starts at over there at 3. It happens inside, so it's a horizontal shift. So far, so good. So we did a horizontal shift, vertical shift, a reflection horizontally and vertically. Those were the easy ones. Now comes the shrink and stretches. Let's do vertical first. Okay, let's look at our equation we have so far. Up until now, which ones have we talked about? X, we talked about C. That's your horizontal shift. The D is your vertical shift. Now, with A and B, we only talked about the signs. If it happens outside, if A is positive, nothing. It's a regular graph. But if A is negative, flip across x-axis. So if A is negative, it flips across the x-axis. It's a vertical flip. So if A is positive, nothing changes. If A is negative, it flips across the x-axis. Same thing with a B. If B is positive, nothing changes. But if B becomes negative, it flips across the x-axis. It's a vertical flip. So those, all we talk about A and B are signs only. Now we're going to talk about numbers. B, C, and D, we talk about numbers, that's horizontal and vertical shift. A and B are simply signs so far. Now, let's look at this function. Vertically, I want to do f of x. That's all I'm going to look at so far. Two things happen. If A is greater than 1, I should say absolute value of A, because it could, if it's going up, it's great. If it's going down, it's also great. If absolute value of A is greater than 1, then we have a vertical stretch. Let's see what this means, why this is so. Nerds, what's happening here is the graph is being pulled either up or down. It's just being stretched vertically. Let's look at the graph. X squared, that's easier. Let's compare it to the graph 3x squared. Remember, A is the coefficient of the function. The function is x squared. So our A is 3. It's greater than 0.
Mhm.
Let's see what happens. So when x is 0, f of x is 0 and g are all 0. That's not a problem. When x is 1, what does f of x become? Yeah, 1 squared is 1. How about g of x? 1 squared is 1 times 3 is 3.
Oh,
When x is 2, what does f of x become?
4,
What does g of x become?
12.
Let's do one more. 3. F of x is, g of x is
18.
3 squared is 9. 9 times 3 is 27. So I'm only looking at the positive side because x squared is a parabola. I'm looking at the positive side. So when x is 0, y is 0. when x is 1. I'm saying the x is the f of x. This is x, and this one's going to be boxes. So when x is 1, f of x is 1. When x is 1, g of x is 3. When x is 2, x is 4. When x is 2, g of x is 9. So this is what it's looking like. Here's the f of x graph. Here's a g of x graph. What do you notice about the two graphs? Yeah, they're both positive, yes, because that's why I put the positive side. We're looking at how fast it's growing. Here's the original graph. If I pull it up, if I stretch it up, I get the g of x. That's what happens because I have a coefficient bigger than 1. So whenever the bigger your coefficient, the faster it grows. So if I had a 5 here, I'd have to have a box here. So it would grow much faster. That's a vertical stretch. So if I have a integer in front of the function bigger than 1, that means from the original graph, I stretch it vertically. If my absolute value of a, actually, if a is between 0 and 1, there's a decimal, then we have a vertical shrink. It pushes it down. You say compression instead of a shrink. It compresses it. Let's use similar functions here. So f of x is x squared. G of x is 1/2 x squared. These are easy to divide by 2. So on the first one, when x is 0, it's going to be 0. When x is 0, it's going to be 0. They all start from the origin. When x is 1, it's 1. 1 squared is 1. G of x, when x is 1, 1 squared divided by 2 is 1/2. These are the y values of my graph. You see automatically, this one's half as big as this one. When x is 4, 4 squared is 16. 4 squared is 16 divided by 2 is 8. So this one's up at 16. This one is only up at 8. 6. 6 squared is 36. 36 divided by 2 is 18. So what's happening here is this. The regular function is that way. This is f of x. This is g of x. G of x is growing half as fast. Because the coefficient's between 0 and 1, yes. But if the coefficient is bigger than 1, then it grows a lot faster. So that's the vertical compression and stretch. Let's look at horizontal compression and stretch. The horizontal compression and stretch. This occurs inside the function. If it happens inside the function in front of x, the coefficient of x, then we know it's a horizontal. Think of this. Remember when we did horizontal shifts and vertical shifts? When do we do horizontal shifts? What letter? A, B, C, or D? C. Horizontal shifts are C. It's inside the function. Horizontal shifts always happen inside the function, whether it's a compression stretch or if it's a shift. Vertical compressions, stretches, and shifts happen outside the function. Okay, so we have a compression. If the absolute value of B is greater than 1. It's a horizontal compression if it happens if B, the coefficient of x is bigger than 1. Let's look at an example here. Let's see what this means. Let's do g of x as absolute value of x and f of x as 2. So since the coefficient of x is bigger than 1, what do you think is going to happen to the graph? You think? Will it grow faster up or will it grow faster out? Well, let's see. When x is 0, that's 0, that's 0. When x is 2, this becomes square root of 2. What does this one become? 2 times 2 is 4. Square root of 4 is 2. Square root of 2 is approximately 1.1 or 1.2. Square root of 2. Let's try 3. Square root of 3. That's still less than 2. It's probably 1.6. This one is square root of what? 2 times 3 is 6. 2.4. So let's look what's happening here. Let's look what's happening here. 1, 2, 3. When x is 0 is 0. At 2, square root of 2 is 1.1. As opposed to, so this is the first one, this is the second one. What at 3? 1.6 as opposed to 2.4. So this is g of x, this is f of x. What's happening here is the graph is being pushed inside. Because this value really is not supposed to get hit until there. So whenever your coefficient is bigger than 1, that means it's gonna be a horizontal compression, which kind of looks like a vertical stretch. And conversely, it's a shrink if B is between 0 and 1. No, it's not shrink, it's compression. This should be stretch. Because if that one's a compression, that's a shrink. This is a stretch. Which means it'll take longer to get the same values. So I told you, is the vertical and horizontal compression and shrinking, those are most complex. Let me show you what this really means now in the whole scheme of things. Function notation. Transformation. And change in points. What kind of transformation is that? What kind of transformation is this? It happens inside the function. You're adding to x. It's a horizontal shift. C units left. Whatever C is, it's going to move left that many units. In other words, what this means is if my original points were that, the new points are going to be x minus cy. Because wherever my original points were, I have to go to the left those many points. How about this function? F of x minus c. What kind of shift is that? It's also, since it happens inside, it's horizontal.
So directly.
Right, correct. C units right. So it starts off at xy. It now shifts x plus c y. Because whatever my original point was, this is 0, 0, I now shifted it to the right, c units. What kind of shift is this one? If it happens outside the function. Has to be vertical, yes. If it happens outside, it's a vertical shift, right? D units up. So every one of these will start from the point X, Y. And then they go to Y plus D, the new point. If it starts off at X, Y, the new point after I do a vertical shift, the X's stay the same. The Y now changes by adding D to it. F of X minus D. Again, it happens outside. It's another vertical. D units down. Y minus D. What's that going to happen? What is that called? It happens outside the function. So is it horizontal or vertical if it happens outside? It's vertical. Says it's a sign change. It's a reflection. Across the x-axis, since it's vertical. And all that does, it changes the x value, the y value from positive y to negative y. Now, if I change the sign inside the function, what happens there?
Yeah, horizontal, right?
It's a horizontal reflection across where? If it's horizontal, it has to flip across the y-axis. So only the x's change directions or change signs. So if the sign changes inside the function, it's a horizontal reflection, and it changes only the x values from positive to negative or negative to positive. What happens here? Now it's no longer just a sign change, it's a number change. So two things can happen. Remember, if the absolute value of A is bigger than 1, or if the absolute value of A is between 0 and 1. What happens in that case? If the outside, if it's bigger than 1, is that what kind of a shrink or stretch is that? Outside is what, vertical or horizontal?
Vertical.
It's vertical. So it's a vertical. Since it's bigger than 1, it's vertically stretching it. It's a vertical stretch. And only thing that changes there is you multiply the coefficient to the y value of a. So if that's a vertical stretch, what is this next one? If it's, no, it's a vertical, it happens outside. Yeah, it's a vertical shrink, right? Again, it's only, all it's gonna do is whatever the a value is, you multiply it to the y value. Now it happens inside the function, the coefficient of x changes. This one, the coefficient of the function changes, this one, the coefficient of x changes. Same things occur. If the absolute value of b is bigger than 1, or if the absolute value of b is between 0 and 1. Since it's inside, we know it's horizontal. If inside the coefficient, if it's bigger than 1, is that a shrink or a stretch? It's a shrink, right? It's a horizontal shrink, or stretch, yeah. If it's a fraction, then it's a shrink. Oh, no, hold it. It's the opposite of this. So this one has to be a shrink. This one has to be a stretch. Because the x's and y's are opposite directions. The change in points are going to be fractional. That's why it's opposite, because it's a reciprocal. Okay, using these things here, I want to see if you know how to use this part here. If I gave you a point, negative, let's make it +3, +5. If you had a point, +3, +5, and you had this function, make it g of x. Here's your point. Here's your function. It's whatever it is. Because what you have to do is label what is A, what is B, what is C, and what is D. So what is A? B, C, D. Very good. Now that you have all these, you can now tell me where the transformation of each of these are going to be. These new points. These are the new points. So what's the horizontal shift? Remember the horizontal shift. We take the x value we have, subtract c, comma y. So the x value is 3. 3 minus c becomes 1, 5. Right here. You see these, forget this part here. The transformation, the horizontal shift is X minus C comma Y. The Y values stay the same on the horizontal shifts. All you do is either add or subtract C to the value of X. So here's C and there's our value of X. Yeah. And then we also have 3 plus 2 for. So 3 plus 2 is 5 comma 5. That's for the second one, the horizontal shift right. Well, how do we do the vertical shift? What do we change there? Yeah, we just change the Y values. So leave the X alone. And 5 plus -3. Then we do a 5 minus a -3.
What's the -30?
The vertical shifts are plus or minus D. What's D? What's the value of D? -3.
Oh,
So the D value is added to the Y. So the new point is 3. 5 minus 3 is 2. So 3, 2. Those become plus 3, 8. Again, it has to change vertically. Is there a reflection across the x-axis? No, because A is positive. It's greater than 0. Is there a horizontal reflection across the y-axis? No, because X is positive. So there's no reflections. How about vertical and horizontal stretches? These last 4. The vertical stretches, you simply multiply the A value to the Y value. Leave the X's alone. So 3. 5 times 3. So it's 3, 15. And how would you do the horizontal shrink or stretch? Yeah, it's whatever your X value is divided by B. So horizontally, it would be 3 divided by 5, comma 5. That tells you your new points. It takes practice. Yes, I'm not gonna lie about that. It's a lot of moving parts. But once you understand it, it's just add, subtract multiple different numbers. Okay, that does it for chapter 2. That's it. We did the first part Wednesday. I know. I'm trying to get to my printer, my scanner froze. So I'm either gonna buy a new one or have Hewlett Packard fix this one. But I can't scan, I can't print, I can't do anything. And I got so much stuff to send out to y'all. The video from last week and everything else. So that's what we're doing. We'll start at chapter 3. Okay, these last 2 sections is on your DMAT, or you're on your math part. And the first 2 are on your DMAT. Chapter 3, only section 1 is in your DMAT. The rest is going to be in your math. You'll find it.
all right.
Yeah, so we're gonna finish chapter 3 pretty quick and then spend a lot of time on chapter 4. This is the 6th week.
So we done it there or not?
Yes. I'm beginning to get.
Taking notes,